Welcome to our Summer 2016 launch webinar with Big Switch, titled New Capabilities of Big Switch SDN Fabrics and How They Accelerate Data Center Network Transformation. My name is Greg Holzrichter, and I'm the Chief Marketing Officer here at Big Switch, and I'll be your host today. Today, joining me is Brad Casemore, Director of Research for Data Center Networks from IDC, as well as Kyle Forster, founder of Big Switch Networks, and Prashant Gandhi, who's our Vice President of Products. As we go through today's presentation, please do feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, or if you have questions of a particular upcoming webinar topic that you'd like our panelists to address, please go to bigswitch.com/webinars and submit a question, and we'll go ahead and provide answers. We also provided you with handouts for today's session, and you can download them from today's Handouts tab on your dashboard. So without further ado, let's go ahead and jump in. We'll do introductions and then go through three different sections, one by Brad, one by Kyle, and one by Prashant. And we wanted to go ahead and set context by Brad talking about the imperative for data center network transformation and some of his thoughts from IDC. And so with that, I'll go ahead and turn it over to Brad Casemore.
Thanks very much for the warm introduction, Greg. It's greatly appreciated, and it's great to be here today. As Greg said, I'm Brad Casemore, and Director of Research for Data Center Networking at IDC. And as the title of this presentation says, I'll be speaking with you today about the imperative for data center network transformation. You'll notice that we use the word imperative, and I think as we go through this presentation, everybody will appreciate why it's a necessity rather than an option. So if we go to the next slide. Thank you. Context, I think, matters in networking more than ever. Networks always have existed to support and deliver the applications that run over them, but in the past, it was easy to lose sight of that fact. We've now reached a point where it needs to be restated clearly and cogently. And a major reason for that is digital transformation, which is happening worldwide and across all major vertical markets. Digital transformation really is an imperative for companies worldwide. Companies that fail to go digital comprehensively so that they can create new customer experiences, improve operational efficiencies, generate new revenue streams, and rapidly respond to changing circumstances will suffer competitively. They might even go out of business. Across a number of verticals, IDC is noting that digital laggards are suffering ominous competitive fates. So if we move to the next slide, we're going to provide a bit more context, and this begins to explain why the network is so important here. The transition to digital transformation, and if we click through, I think you'll see a little bit of a bell here. There it is. The transition to digital transformation takes place on what IDC calls the third platform. The third platform comprises cloud, mobility, data analytics, and to a lesser extent, social business. It's enabled by a number of innovation accelerators, including the Internet of Things, next generation security, and the others you see there. Digital transformation leverages these innovations to generate the business benefits and value we covered in the previous slide. The important thing to take away here is that the network is increasingly important to the third platform, to innovation accelerators, and ultimately to digital transformation. Its role actually is increasing in this whole context. We move to the next slide. Not surprisingly, market growth will occur on the third platform, and that's really what this chart is showing you. You can see the growth rates during the forecast period, which runs from 2015 to 2020. You see a CAGR of 12.7% for third platform ICT, as compared with a CAGR of negative 4.8% for second platform ICT, which is really representative of the client-server era and more traditional IT practices. We move on to the next slide. I mentioned that cloud is integral to the third platform and to digital transformation. Every year, IDC conducts a worldwide cloud view survey, and this year, of course, was no exception. You can see that we asked respondents, how would you best describe your organization's current or near-term plans to use public or private cloud solutions to support production workloads and services? And you can see the response. About 75% are embracing or deploying, and another 15% are evaluating. Of course, the important thing here is that 10%, only 10% are not interested. I can tell you that these results showed a significant uptick among those embracing and deploying from the previous year. Cloud in this context, by the way, just so that we're clear, cloud in this context, by the way, includes both private and public cloud. I think this slide is important and really is really important for the context of the presentation because cloud adoption has a direct correlation on data center network requirements, and we're going to talk about why that is on the next slide. Sorry, that was a bill. There we go. Really, I think it's important, it brings us to SDN, and SDN, it's important to remember that SDN originated as a demand-side customer pull technology, not as a supply-side vendor push technology. I know vendors, of course, have gotten involved in the dialogue since then, but SDN arose initially to support the needs of cloud computing, and the early adopters were hyperscalers and other large cloud service providers. For these organizations, IT is their business. It's what they do to generate revenue and earnings, and the data center is really at the heart of their business. So it's critical that their data center network contribute directly to the bottom line. Now, what's happening now as enterprises embrace digital transformation and adopt cloud, they're confronting many of the same challenges that were first met in the public cloud and in the hyperscale operators. As a result, enterprises are looking to emulate the best practice hyperscalers with some notable caveats, of course. One challenge is the skills gap in areas such as network automation, programmability, and orchestration. The enterprise, just doesn't have the resources that the hyperscalers have in those areas. The skills gap's not going to dissipate overnight, so enterprises are going to look to vendors to adapt and repackage hyperscale-type technologies so that they're consumable, deployable, and supportable in an enterprise context. I think this is really important. The way hyperscalers did it, there's some great things that can be emulated, but they need to be almost repackaged and represented for enterprise use. So if we move to the next slide, we can see here we're just talking common use cases for SDN and network virtualization in the enterprise. The first one, business and operational agility, will be increasingly ubiquitous as we continue the move to digital transformation and cloud acceleration continues apace. But we also see some other use cases, and there are a number of others. We presented some salient ones here. There's also data center security for east-west security in the virtualized data center and security analytics, a lot of microsegmentation being applied in this context. And there's business continuity and disaster recovery, which becomes especially important in a cloud context. Again, the drivers are increased server virtualization. We knew that had already been happening, but also adoption of the third platform, especially cloud, which is a huge driver for a lot of this change. And if we move to the next slide, this is from a different survey IDC did. We did this survey back in September, and we asked respondents, this was an SDN survey, and we asked respondents, if you are implementing SDN, which of the following factors is the primary motivation? You can see that motivations vary, but there are some common ones that really came through. One, of course, is the need for agility and the need for better automation and programmability. Those were prominent considerations. But security also was very prominently cited by enterprise respondents. Enterprise respondents are in the light blue, and cloud providers broadly speaking, including SaaS, PaaS, and infrastructure as a service providers are in the dark blue there. But you can see obviously some commonalities across both camps. If we move to the following slide, we know that network disaggregation, has certainly occurred among the large hyperscalers and in the public cloud. So we asked about it in our SDN survey. We asked respondents in both the enterprise and the cloud camps whether they had considered running a third-party NOS on their network hardware. And the results, even among enterprise respondents, were surprising. You can see here that the yes camp, even for the enterprise, is at 44%. It was slightly greater than the enterprises that said no. Among cloud providers, of course, the percentages are even greater. Very few are not aware of this solution. Now, there's a difference between considering and buying, but This is really healthy interest. And I think it's another example of how a lot of enterprises are looking at how they can emulate cloud best practices as they embrace cloud in their own environments. We move on to the next slide. I think this is really important, and I want to get to this, particularly because we discussed the imperatives of digital transformation in cloud. In the past, I think something akin to a conspiracy of complexity existed between network vendors and the network professionals who were their customers, the ones who procured, deployed, and managed network equipment. Vendors produced increasingly complex gear with proprietary features and protocols, or proprietary extensions of industry standard protocols, and they added nerd knobs and other stuff. And their customers, the network operators, who saw themselves as certified masters of complexity, embraced that complexity because they felt it was good for their businesses and, frankly, good for their career longevity. But really, this arrangement has become untenable. It can't continue anymore, and it's untenable because of what we talked about earlier, the disruption and business imperatives unleashed by cloud and digital transformation, respectively. No vertical market is immune, as we said earlier, and the status quo, both in terms of the way they do business and how they support that business with technology, just cannot hold. The networks must change. They need to become more agile. They need to become more flexible to support what organizations and businesses need to do within the context of digital transformation and cloud. And the problem, though, I mean, that organization space, and it gets back to what I said about the solutions. The problem is that we also have a skills gap, right? There's a cloud skills gap in many enterprises, and that means simply emulating what the hyperscales did is a daunting proposition. They're going to have to have this technology repackaged and adapted for their requirements and their application environments. But I think at the end of it, and certainly something I want to reiterate here, is the conspiracy of complexity, as I called it, maybe a little bit of hyperbole, but it was once seen as beneficial for vendors and their customers. It must end. We're reaching a point where, networks need to become simpler. They need to become simpler to consume, simpler to deploy, and simpler to manage. And now, just to sum up in the following slide, I think as essential guidance, I want you to take away from this that digital transformation, which is on the third platform, is a critical enterprise imperative. It's happening worldwide, it's happening across all vertical markets. As a result, network transformation, including increased network agility as a centerpiece, is a key requirement in this evolution. SDN should be seen as an architectural response to these new requirements, not as, the latest iteration of networking for networking's sake. For enterprises, SDN solutions must become less complex, easier to deploy, and simpler to manage. And with that, I'll hand it back to Greg for the next stage of the webinar.
Great, Brad. Thank you so much for sharing those insights. It's always great to see insights backed by data, which is what IDC is so well known for. We're really excited to see some of these trends coming together, and really in this next phase, we wanted to talk by a presentation by Kyle Forster, our founder, talking about how Big Switch is addressing some of those issues that you've highlighted. Kyle?
Sure. Well, thanks, Greg. This is just an incredibly exciting time for all of us here at Big Switch. Look, I think Brad's data is pointing to a market in transition, and that is absolutely what we're feeling here. We're coming on 2.5 years of hockey stick growth. The open switch hardware and SDN software technologies, really the two technologies on which our company is predicated, are crossing the chasm. You've seen Brad's data on our side, whether it's website visits or people trying our online labs, whether it's people signing up for our email newsletters or people watching webinars. Nearly every leading indicator that we have on the market has tripled in the last 12 months. In this time period, people ask us a lot, how do we think about our mission? Beyond the technologies that we represent, we're taking designs that we've found in hyperscale data centers, and we're bringing them to the broader community. While many of us, I think, for years looked enviously at the networks that were in place at Google or in place at Facebook, what we're finding now is a broader and broader group of people that can absolutely emulate that for parts or all of their data centers. And this is just an exciting time. Now, I remember when we started the company, very frequently in meetings I would get back, well, look, hyperscale design, that works for them, but it'll never work for me. And I am so happy to watch us, one data center at a time, put that question to rest. Our hyperscale designs for everyone, our hypothesis is yes. And more data centers are showing it. 16 times faster configuration upgrades, 4 times faster application deployment, 40% TCO, 12 times faster troubleshooting. All of these things are improvements that we are seeing every single day. As a company, we're focused on 4 use cases. These are really the 4 areas that we felt were screaming for improvement. On the switching side in Big Cloud Fabric, we're very focused on OpenStack. We felt like there were a series of networking problems to be solved there that we could solve with our core technologies extremely well. We're very focused on the VMWARE portfolio. This is vCenter and this is NSX. I think as we found, there are a series of, frankly, efficiency improvements that we can make into the underlying physical network, into leaf-spine switching, for both standard vCenter and for NSX, that we feel bring the benefits of hyperscale networking to the broader audience. And then on the monitoring side, big monitoring fabric, this is the NPB area of our business. As everybody I think on this call probably knows, we started with NPB topologies that were really for pervasive visibility and security. With the technologies that we have, we can scale monitoring fabrics and monitor large-scale monitoring fabrics vastly more easily than traditional NPB technologies. But with a new topology that Prashant will talk about here shortly, we're taking the same underlying technologies and applying them into the DMZ, dramatically simplifying these increasingly complex chains of security tools that we're seeing out there in the industry. So it's exciting for us, here in this evolution of our company, watching the core technologies that we've been working on for the last 6 years, watching them apply to more and more of these cases and watching these benefits show up in more and more data centers. This slide makes me very, very proud. This is a sampling of some of the groups with whom we were engaged. I think what you'll see is a spread of different industry verticals. I think what you'll see is a spread of both monitoring, switching, and several that are both monitoring and switching deployments for us. But I think to me, that as I look at this, frankly, from where I sit in the company, we embarked, about 4 years ago now on a distinct strategy that was what we call the lighthouse user strategy. In every vertical we go into, in every geography we go into, we try very hard to work with the most sophisticated teams in that area as our end users. It takes incredible patience. It is backbreaking work. It's not traditional sales work as you'd think about it, because these are high-end engineering teams that require very, very deep engagement. And when I look at this slide and I think of the incredibly sophisticated teams that have sat on the other end of each of these engagements, knowing what the trust that our teams have built together, this slide makes me very, very proud. So let me at this point turn it over to Prashant for a tour through a series of product updates that we have as part of this launch, and take it away.
Perfect. Thank you, Kyle. Indeed, it is very exciting. We were here last January to provide an update, and here we are in a very short period of time, a few months, to discuss new capabilities and new use cases. As Kyle pointed out, our focus has been on 4 main deployment models, 2 for big cloud fabric in OpenStack and VMware environments, and 2 for big monitoring fabric, one in the out-of-band mode and the other in the inline mode for DMZ security. And thus far, we started out with use cases and expanded the deployment models. Today, what we will talk about is within those 4 deployment models, how we are bringing additional depth so that we continue to increase the diameter of deployment options that our customers have across these 4 use cases, but with a broader and broader ability to support workloads and capabilities. So with that, let's first start with big cloud fabric, and let's look at what we have done here, specifically in the area of OpenStack. A couple of months ago, VERIZON described their telco OpenStack based NFV cloud with the architecture that relied on Clos Fabric, SDN operating system, and OpenStack orchestration to build NFV. This has been deployed across multiple data centers and tens of racks, and leverages a very open stack made up of open hardware, Big Switch SDN software, and Red Hat OpenStack orchestration. And the open networking switches are from Dell. So this provides VERIZON a very open environment with complete vendor choice at every tier. And this is really, as Kyle pointed out, the style of hyperscale networking that is very much available in enterprise and telecom environment. This one specifically designed to enable production-grade, scalable, and highly resilient NFV clouds. So what does this entail as we move forward and enable and accelerate NFV across a broader deployment footprint? And as we have discussed this use case with a number of telco customers, their input has been is that we have multiple locations within our network where we have space and power, and we would like to place NFV servers and NFV services to our mobile and end users, wireline users, business users, through these various locations. And so how do we enable this vision of NFV and take it everywhere? And so in our discussions with these customers, we have found that their interest is to deploy NFV at not just the data center, but also in central offices. And one of the requirements in central office is NEBS hardware. And so we are now supporting NEBS hardware both in the form of the hardware controller as well as NEBS switches to now enable a large number of central offices where NFV can be served from. Now, even an order of magnitude locations are within a variety of regions served through smaller points of presence. And here one can deploy, our telecom customers would like to place anywhere between 40 to 80 to 100 servers to offer localized NFV services. So we are enabling this use case by supporting a virtual machine-based controller. And this way, our telco customers can consolidate their OpenStack and SDN controllers into a common virtualized servers, thus save space and power and allocate all of that to as many NFV servers as possible. So highly efficient way to deliver NFV from small points of presence environments. Finally, to me, a very exciting use case and a deployment model is in a metro area. In a metro, there is a regional data center or central office, and they are connected over an optical metro ring with multiple remote POPs. These are very small environments that serve last mile and have, in many cases, additional space and power to put a dozen, 2 dozen servers to serve NFV for local environments. These could be content optimization, web caching, management of the last mile, troubleshooting apps for the last mile. But because of the constraint of space and power, how do we deliver NFV in a very efficient way? And so what we have done is to essentially split the fabric, the big cloud fabric, in such a way where the big cloud fabric controller and the spine layer resides centrally in the data center or the central office within a metro region. And each rack, the leaf switches in each rack, can be detached and placed into a remote point of presence. So in this manner, one can serve many, many remote points of presence connected through an optical metro WAN for allowing predictable latency. And now we can have this one big logical switch in the form of big cloud fabric managed centrally through the data center, but now enabling services remotely through remote points of presence. So very exciting way to bring NFV services everywhere within a telco environment where there is space and power. Resiliency is equally important in OpenStack in addition to scale and simplicity of operations. How do we bring resiliency? And this is a hallmark capability of Big Cloud Fabric, which is built leveraging a unified physical plus virtual network environment. In other words, with P plus V, Big Cloud Fabric operates in a unified manner, offering a single network for virtualized environment as well as the physical leaf and spine. It allows us to offload neutron networking onto the fabric and enable distributed virtual routing, floating NAT, all of these important services in a highly distributed manner, in a scalable manner. And what we have done, leveraging Dell's Open Networking Scale Lab to test the entire solution with Red Hat OpenStack 8, Big Cloud Fabric, and Dell switching across leveraging 300 Dell servers, and shown that within torture test environment at full scale, that application performance remains unimpactful when during failure events. And so this is very important for customers to have the confidence to deploy the stack in a production-grade, scalable NFV environment. Now, with NFV, in addition to NFV, we are now expanding use cases in storage space as well, IP storage specifically. What we have done thus far is to support traditional storage that operates on iSCSI and NFS protocols. The Big Cloud Fabric operates in a lossless manner. It can be designed to be non-blocking, very high performance at 10 gig, 40 gig, with full quality of service. And this has allowed us to deploy traditional disk arrays as well as even flash-based devices to enable IP storage traffic on Big Cloud Fabric along with data traffic. One of the areas where we have a huge differentiation and provide tremendous value that customers see is in automation and visibility. We enable this through integration in both VMWARE environment as well as OpenStack environment, as we have seen in the NFV use case. In the case of VMWARE, we are able to automate the network on the Big Cloud Fabric, provide full troubleshooting and visibility as VMs communicate with each other or the hosts communicate with each other. So with that, we have extended the use case now to support VMware Virtual SAN, which allows us to bring hyperconverged infrastructure with SDN Fabric's capability in network automation and visibility. And I'll talk more about that in the next slide. And finally, software-defined storage. We are seeing increasing number of customers wanting to leverage large-scale, petabyte-scale storage as warm Tier 2 storage in their environment, and in a very economical manner, leveraging open commodity hardware. We are leveraging Red Hat Ceph to enable software-defined storage, and we already have existence proof points of how this is implemented in NFV environment, for example, but also in areas where we see opportunities such as cloud storage as well as multimedia storage. And leveraging OpenStack, we continue to provide full resiliency, scale, automation, and visibility. Let's dig deeper into hyperconverge. The fact that we can connect to any hyperconverged environment is very apparent through the fact that Big Cloud Fabric can operate as a network fabric, leaf-spine fabric. In a VMware virtual SAN environment, we offer additional capabilities in terms of automation. What kind of automation is that? Well, when a VI admin is connecting new VSAN nodes, there is no need for network configuration of the top-of-rack switch. It is all automatically done. Hosts are automatically detected. Top-of-rack switches are automatically configured for link aggregation. Virtual SAN, through VM kernel, requires a transport network on the fabric. With Big Switch Fabric's API integration into vCenter, we are able to automatically create the network segments necessary for vSAN network. So as additional leaf switches or spine switches are added in the fabric, as hosts are added in the network, all of that automation takes place in a zero-touch manner. No additional network intervention is required. Also, because of the fact that Big Cloud Fabric operates as one big logical switch, multicast, which is often needed in these environments to replicate traffic, is a single button capability. And here, with one click, one is able to create multicast across the network when there is change management, adding of new switches, leaf or spine. There is no additional configuration is required. So from automation perspective, visibility perspective, troubleshooting perspective, we are able to bring these new capabilities in virtual SAN environment to enable the hyperconverged infrastructure use case. Basically, 3 steps to enable this, with Big Cloud Fabric. Register with vCenter, enable multicast, and now network is out of the way. The vCenter admin can deploy vSAN, create clusters, add new nodes, remove old nodes at will, with the speed that they demand. And in terms of troubleshooting, we provide a GUI environment in vCenter so that even the VMware admin is able to have the fabric visibility and is able to troubleshoot the traffic going across the leaf-spine leaf fabric. As we have enabled these use cases, now customers have also asked, what about scale? Today, thus far, we have supported 32 leaf and up to 6 spine, so fairly large fabric. And the scale of the fabric is directly correlated with the density of the spine switch. For a 40 gig spine, today open networking switches, the maximum density has been 32 ports, and hence the Big Cloud Fabric has supported 32 leaf switches. This is a fairly large fabric. It can support over 600 servers. Depending on the VM density, assuming average 20 to 1, one can support over 12,000 virtual machines. So indeed a very large failure domain or blast radius. However, a set of customers are now looking at expanding even beyond this size. And so we are enabling, with this announcement, a doubling of the fabric scale, leveraging Dell's most recent announcement of Dell S6100, a modular switch which can, when fully populated, support 64 40 gig ports. So by doubling the fabric, we are able to now, support over 1,200 servers, nearly 25,000 VMs. So clearly a huge cloud infrastructure can be built with this new scale capabilities. There has been a lot of excitement in containers. And as we have seen, the application form factor, which used to be a bare metal server, then moved to virtual machine, is now leveraging container as a new atomic form factor for application deployment. This has allowed app developers to simplify the creation of applications, testing of applications, and deployment of applications in production environment. The time it took to build, test, and deploy applications can be significantly reduced with container environment. Also in containers, we are seeing that an app that would have typically resided within a VM form factor is now distributed across half a dozen, even more number of containers, which means the app itself is becoming highly distributed. And when there is application that is highly distributed, it requires a network to support inter-component communication for that application. And hence, the network becomes super critical. What Big Cloud Fabric has done is our ability to integrate very rapidly, as we have seen with OpenStack Neutron environment or in VMWARE vCenter environment, through a API integration or through a plugin, allows us to extend automation, visibility, operational simplification very quickly into these new environment. And with containers, we are able to do the same thing. And we have done multiple technology previews of how we can support container networking, leveraging Big Cloud Fabric through our controller's ability to do API integration. We started out last fall with Docker integration, and we showed with a plugin in Docker Engine that we can automate networks and provide full container-to-container visibility on the network fabric in Docker environment. Recently, a few months ago, we supported the Mesosphere's DC OS launch, where data center operating system operates across multiple servers and allows a formation of a logical compute environment. And it is highly synergistic with the Cloud Fabric, which operates as a logical switch. So ability to now deploy new class of applications directly on DC OS, and then supporting network automation and visibility on Big Cloud Fabric. With this announcement, we have extended Big Cloud Fabric in Kubernetes environment, where with our plugin in Kubernetes master cluster, as well as on the host, we are enabling automation where Kubernetes container orchestration system would orchestrate a container, create a container on a given host, and the Big Cloud Fabric creates the virtual and the physical network. It also supports the container-to-container visibility and troubleshooting, as we are able to trace the path all the way from container to source virtual switch, source leaf, spine, destination leaf, and the destination virtual switch. So no more worrying about networking, whether it's traditional physical server environment, whether it is virtual machine environments in OpenStack or VMWARE, or whether it is up and coming container environment. So those are our announcements for Big Cloud Fabric. I will now go into Big Monitoring Fabric and discuss how we are extending the two use cases, one in the area of out-of-band monitoring and the other for DMZ security. Let's first start with out-of-band monitoring. Here, typically a customer has a production network where application interactions occur. East-west traffic needs to be monitored and secured. And many of these customers would like to monitor their environment, secure their environment for all types of traffic within the data center, any flow, anywhere in the data center. And for that, they would enable span on switches and routers. In many cases, they would leverage optical taps and bring that traffic to a set of tools. Because of the fact that one has large number of 10 gig and 40 gig links that need to be processed, there is an emergence of what is called a network packet broker, which acts as an aggregation entity and provides additional services to this traffic that is copy of the original traffic and redirects it to a variety of tools such as network performance management, application performance management, security monitoring. In addition, there are additional services that are attached, as we have shown with Big Monitoring Fabric connecting to service nodes, whether it is a Big Monitoring Fabric service node or a third-party service node, where services such as deduplication of traffic, slicing of packets, regular expression matching, and redirecting this traffic to the tools that are interested in those specific flows. What Big Switch has done is to develop a service node that is completely open on an x86 server, leveraging DPDK, Intel DPDK, to provide very high performance services. We already provide 40 gig service for dedupe, packet slicing, and regular expression matching. And these nodes can be deployed in a scale-out manner so that large hundreds of gigabytes of packet services and flow level services can be applied within the Big Monitoring environment. All of this, both the fabric itself, monitoring fabric itself, as well as the service nodes, are controlled and managed through the same Big Monitoring Fabric controller. With this announcement, we're announcing additional services on the service node. The first one is header stripping. When traffic, increasing amount of traffic is encapsulated with VXLAN, with MPLS, ERSPAN, variety of headers, and it is inefficient for the tools to remove this header and focus on the original packet for the purpose of monitoring. With the service node's header stripping capability, we can offload that expensive operation directly in the fabric at very low cost in a highly operationally simple manner and allow the tools to do what they do best in a very efficient manner. Another service, very exciting, is net flow generation. Oftentimes, customers are reluctant to enable net flow on the original network, on the network where application traffic is connected, because it may impact the performance and resiliency of their original network, production network. So with Big Mon service node, we can enable net flow generation directly in the fabric and enable customers to do flow level monitoring, security, and performance measurements. It's a very exciting service, and it is now entering beta, and we will be having it available as we go through the beta process. The second use case of big monitoring fabric is in the DMZ. And here, between the DMZ firewall and internal or inside trusted zone routers, customers, in order to secure their data center applications and user traffic, would like to place a variety of security tools: SSL decryption, advanced threat protection, intrusion prevention, web proxy, denial of service attack, as well as as traffic is becoming more and more SaaS oriented or leveraging SaaS services, CASB, in order to provide SaaS visibility. The biggest problem is change management, as security teams and network teams need to, collaborate in order to make the changes occur in DMZ, which can, through the ticketing dependencies, can take much longer time to deploy. And also ability to create service chains for different categories, risk categories of traffic. For internal traffic and originated from the enterprise, it may need to go through one set of security tools. And if the traffic has higher risk profile or is emanating from certain geographies which require additional security, then it needs to go through a different security chain. And this all needs to occur in a simplified manner to create policies and change policies. And Big Monitoring Fabric provides that in a very simple way, enables this change management by leveraging traditional Ethernet switches, open switches at 10 gig, 40 gig, and 100 gig, to be placed between the firewall and the data center core router, and enabling services to attach to the inline switches. Monitoring is done centrally. Many services can be attached, and policy-based service chains can be created using a drag and drop menu. And we are, partnering with Blue Coat, FireEye, and A10 to provide full deployment guides to enable a highly secure DMZ environment, leveraging BigMon's inline capabilities. We're also extending BigMon to scale, leveraging Dell S6100 to bring additional density, double the density of 40 gig ports, as well as bring a new form factor to support 100 gig monitoring environments. And with that, Greg, what we are also doing is expanding the platforms, hardware platforms, to support Trident 2, Trident 2 Plus platforms. We today support Trident 2, 40 gig platforms, 10 gig platforms, and in addition, we will be supporting the 10G-based on the Trident 2 Plus platform, both from Edge-core open networking switches as well as Dell open switches. Those are all the announcements for the summer, Greg.
Great, Prashant. Thanks so much for taking us through all of those innovations in both the Big Cloud Fabric as well as Big Monitoring Fabric solutions. 2015 was really interesting in that we had a lot of these, early SDN deployments, a lot of POCs, early production deployments, and this release really kind of exemplifies that larger production rollout. And so this concept of being able to support any enterprise, any workload at any scale is really kind of what these innovations represent. And one of the things that we wanted to reiterate with this launch is this focus on our Community Edition. And so, Community Edition was the free version of both of these solutions that we made available back in January, where we've had hundreds of people actually download this and deploy it in their own labs. And so what we wanted to do now is, further invigorate that growing community by launching a sweepstakes or a contest. And so we're inviting the community to come up with and submit innovative use cases in your own environment. Submit those on the Community Edition site, and there's a link here, bigswitch.com/Community Edition. and we have a panel of judges that will be reviewing all of those. For the 4 winners that actually are selected, we will actually send both our a free version of physical hardware switch as well as the free Community Edition software. So please take a look at that, and we invite you to participate. So now we're going to move over to the Q&A section of our session. We've had quite a number of questions coming in throughout the conversation. And so the first question is, how does Big Cloud Fabric compare or interact with data center overlay solutions? And I'll ask Prashant to answer this one.
Yeah, excellent question. The overlay solutions essentially build a network leveraging virtual switches. These overlay networks traffic certainly needs an underlay to communicate across the virtual switches. And Big Cloud Fabric, which is in the form of a leaf-spine cross fabric managed through the controller, acts as an underlay. In fact, we have shown interoperability with VMWARE's network virtualization solution, NSX, where Big Cloud Fabric provides tremendous visibility and closes the gap, the visibility gap, and provides troubleshooting instrumentation so that one can quickly find out whether the issue is on the underlay or the overlay. So we support overlay environments in VMware environment. In KVM, certainly that is also possible, but we have seen customers gravitate towards the Big Switch's P+V solution, which provides a unified network across both virtual and physical. And if we look at the NFV use case, the P+V-based OpenStack fabric is highly attractive as it provides highly simpler and automated experience across both virtual and physical environment.
Great, Prashant, thanks so much. And another question that's come in is, does Big Cloud Fabric support VXLAN within the fabric and to connect intra or inter data center?
Absolutely, and I think it's something that we didn't go into any detail with this announcement, but Big Cloud Fabric release is supporting VXLAN. We are leveraging that to enable interpod connectivity or L2 extensions, as well as customers have expressed interest in extending L2 over their L3 environment across data centers. And we would be supporting these use cases as well. So VXLAN, absolutely first-class citizen.
That's great. And so another question, this one is for Brad. In terms of the inbound requests that you're getting, could you comment on the profile of the customers who seem to be interested in starting on the SDN journey?
Actually, we're seeing interest from a broad range of customers now. In fact, I think you guys have seen a similar thing in your customer base, that the addressable market has expanded over the last while. But we see everybody from CSPs to very large enterprises, Fortune companies and more international companies with international operations that may not necessarily be Fortune, but are very large companies. And they're very interested in how they can emulate a lot of the best practices that they're seeing in the public cloud, and they have the drivers that we discussed earlier.
Great, thanks, Brad. And so the last question, and this one is for Prashant, can you expand on why monitoring and troubleshooting VMware vSAN is easier when it's running on top of Big Cloud Fabric?
Absolutely. If we look at, because we integrate with, or the controller integrates through APIs with vCenter, we are able to display complete virtualized environment, such as virtual machines, the host information, directly in the controller. This allows network administrators to have visibility to virtualized environment, and when issues occur, interact with VI admins with that additional knowledge of virtualized environments. Similarly, what we have done is provide fabric visibility to VMware admins or VSAN admins directly in the vCenter GUI. With the Big Switch's GUI plugin, we are able to show how a VSAN host connects to the fabric and whether that connection is fully connected, whether the links are up. All of this visibility is provided, exactly which ports to which the VSAN host connects to the fabric is provided. Additionally, we have enabled troubleshooting where whether it is a network admin or VSAN admin, in their own consoles, they can enable a testing of connectivity of two VMs or two VSAN hosts across the fabric. And we display the full path from the host into the leaf switch to spine over to the destination leaf and destination host to the destination VM, and also resolve link aggregation so that actual links that are being leveraged for that specific flow are displayed. And they're displayed both on the Big Cloud Fabric's GUI for the benefit of the network admin and exposed in vCenter GUI for the benefit of the VMware or VSAN admin. And this way, both of them see it very consistently. And you know, oftentimes 60–70% of the problem is to identify which domain the issue resides in, whether it's network or virtualization environment. And with this, we're able to take that very important first step and resolve it very rapidly so that the domain-specific team can then go and troubleshoot further.
That's great, Prashant. Thanks so much. And that is really exciting as a step towards this vision of the software-defined data center and really bringing network automation and simplicity to that hyper-converged kind of concept of compute and storage. So we'll be watching that as it develops closely. With that, I wanted to transition over and thank everybody for attending. If you are interested in learning more about Big Switch technology, we have a very interesting environment, a hosted environment we call Big Switch Labs. We've had over 3,000 folks register for that. You're able to spin up and manage a solution, both Big Cloud Fabric as well as Big Monitoring Fabric. We have over 11 live modules that are self-paced and allow you to get started. We also have free software, as I mentioned, that is available as a community edition. Download that and take it for a spin in your own lab. And we encourage you as well, if you'd like to get started with the proof of concept, we make that very easy with our Big Switch starter kits. And if you're interested, please contact info@bigswitch.com to get engaged with somebody from Big Switch, and we'd be happy to understand your environment and get started. And finally, I wanted to flag our next webinar in the Big Switch webinar series, which is on July 13th, featuring our solution, our joint solution with Riverbed and Big Switch. As Prashant mentioned, we're focusing a lot more on our tech partnerships with leaders and showing how our Big Monitoring Fabric really is an ideal solution to get the most out of network visibility and monitoring. And with that, I wanted to thank everybody for joining this summer launch webinar, specifically our presenters, Brad, Kyle, and Prashant. And thank you again for joining us today.